Recording. Not recording. Recording. All right, here we go. So we'll do these questions one at a time, and hopefully it will help you with your test, which is scheduled probably for Monday, by the way. So the first question is, can I write on this? Yes, I can. It costs $80.88 for 6 necklaces. What is the cost for 1 necklace? So you're looking for the unit rate, right? So you can do find K. You can several ways you can do this. So let's do it this way: 80.88 N for necklace. No, dollars. Sorry. Divided by 6 necklace. No, just write N. And you want 1 necklace, so you can divide this by 6, and you can divide this by 6, and that should give you 80.88 divided by 6. That's going to give, 80.88 divided by 6 gives you $13.48. Now, if you want to do, what do you call, K equals YX, you'll notice that's the same thing. You're still dividing 80. You're dividing 80.88 divided by 6, and you're going to get that K, your constant proportionality, is 348. And if you want to take a step forward, you can write Y equals 13.48. So each necklace is 13.48. Okay, so all this they're all related. Same thing. You want the weight of 1 baby. So you got 45 kilograms. And you got 1 baby over here. So again, this one you can divide by 8. Divide by 8. And you're going to get that 45 divided by 8 equals 5. 1 baby is going to weigh 5.625 kilograms. Okay, again, this would be your X. Sorry, this would be your Y. This would be your X. So if you did K equals YX, you would get 45 divided by 8. Isn't that what you did over here? 45 divided by 8. So K would be the same. So this will be your K. And your equation would be Y equals 5.625X. Third one, you're asked to complete the table, right? You have a table over here. So you need to find the relationship. So again, you can do this. So again, you can find Y and X. So this is Y, X is always your time, right? And if you did K equals Y over X, you find the proportionality here, the constant proportionality, so it would be 40.5 divided by 3, 40.5 divided by 3, and that's going to give us 13.5. So the constant proportionality is 13.5, and if you did this the same way, 121.5 to 121.5 divided by 9 equals 13.5. So you can see the relationship here, right, is times 13.5. This is also times 13.5. So everything is going to be times 13.5. And this is also going to be times 13.5. So it's just a matter of multiplying. 5 times 13.5 equals 67.5 for this one. And the last one is 13 times 13.5. That's going to give us 175.5. So that would be the missing values. Okay. Let me get some space here. Marks walk 1/6 of an hour in 3/5. 1/6 of an hour. Takes Mark 1/6 of an hour to walk 3/5 of a mile. What is the unit rate in miles per hour? It says per hour, so the hour should be at the bottom. 1/6 of an hour, 3/5 of a mile. We want to know how much he does in 1 hour. So I'm going to multiply this by what? The reciprocal, 6 over 1. And multiply this by the reciprocal, 6 over 1. This will cross out. You're going to have 1 hour, right? And then on top, you're going to get 3 times 16, which is 18. 5 times 1, which is 5. Or 5 goes into 18 3 times, and we have 3 left over 5. So 3 3/5 of a mile in 1 hour. That's the better way to write it. 5. There are 5 apples, 14 pears, 16 oranges. What is the ratios of oranges to fruit? So again, we want to compare how many oranges are there to total fruit. So how many oranges do we have? We have 16 oranges. And remember, ratio, we can write it like this, 16:2 or 16:2 or 16 over a fraction over. But we need the total amount, right? So the total amount is going to be 5 plus 14 plus 16. We want the total amount of fruit. So there's 5 plus 14 plus 16, which is 35. And you can write it in all these 3 ways. Okay. Number 6. Sam pays $7.70 for 14 pencils. Write an equation where T represents the total cost and P represents the number of pencils. So T is the same thing as Y, and P will be X. So we want an equation Y equals KX, or in this case we want T equals KP, right? So we're missing how much is it per pencil. So the dollar would be your Y, and the 14 would be your X. So to find K, which is the number that we're missing, we go 7.7, which is Y, divided by 14. 7.7 divided by 14 equals 0.55. So our equation would be Y equals 0.55X, but they don't want us to use Y and X, so we're going to replace the Y with T. The 0.55 stays the same, and the P and the X we're going to change for P. So the total is 0.55 times however many pencils you buy, right? If you buy 1 pencil, it would be 1 times 0.55. If you buy 2 pencils, it would be 2 times 0.55, and so on and so on, right? Numero 7. Tim uses 1 1/4 cup of milk to make 12.5 mini cheesecakes. How many mini cheesecakes can he make with 1 cup of milk? So let's find the unit rate. So let me write 12.5 mini cheesecakes, mini, and with 1 4/5 cup of milk. But I want to know how much cheesecake can I make with only 1 cup of milk. So it's the unit rate, right? But before we do that, we might want to change this to an improper fraction. 5 times 1 is 5, plus 4 is 9, so it's 9 over 5. 2 times 12 is 24, plus 1 is 25 over 2. So again, the same thing, I just rewrote it, so it's mini cheesecake, and then milk here at the bottom. I'm going to multiply this by the reciprocal, right, which is 5 over 9, and times 5 over 9 on the top. On the bottom part, these two, I'll simplify to 1. And on top, I cannot simplify, so it's 25 times 5, which is 125, and 2 times 9 is 18. And we're going to change this, okay, we're going to change this, and to 18 goes into 125, hang on a second, 125 times 7, 18 times 7, it's going to be 6 times, or 6 times 18 is 108, and 125 minus 108 is going to be 17 over 18. So you can make 6 and 17th over 18 minus cheesecake, and 6, almost 7, but not quite. Okay. Number 8. Which graph shows a proportional relationship? How do I know? Well, we discussed about this, right? If it's proportional, there's one thing on the graph that you're going to be looking for, which is, does it start at 0, 0? And this one does, and this one does not. So this one is not proportional, and this one is. Okay. Number 9. Sam can say 140 words in 35 seconds. What is the constant of proportionality? So in this case, this would be my y, and this would be my x, right? So the constant proportionality is k equals y over x. So k equals 140 divided by 35, and k equals 140 divided by 35, and k equals 4. Now, which of these tables show a proportional relationship, and how do I know? Let's take a look at table A. Let's find the constant proportionality here, right? So we'll do, for table A, we'll do k equals y over x. And so let's do 10 divided by 6. 10 divided by 6 equals 1.6, 66666. So with a bar notation. Let's do 14 divided by 8 to see if this is the same. 14 divided by 8. And that's k equals 1.75. So here and here, this is 1.6. This is 1.75. And I don't need to, and 18 divided by 10 is 1.8. So all of these are different. This is different and different. So table A, it's not. Let's do table B. And we're going to do y over x again. And y is 12 divided by 3. 12 divided by 3 is 4. This is 4. 16 divided by 4 is 4. 20 divided by 5 is 4. So all of these are the same, right? All k's are the same. So definitely B. Let's look at table C. K equals y over x. And k equals 14 over 7, which means k equals 2. So this relationship is 2. Divide by 2. 20 divided by 2 is 10, so it's the same. 34 divided by 2 is 17, so they're all the same. So table C is also proportional. A duck can swim 2 miles in 5/8 of an hour. How much can he swim in 1 hour? So in 1 hour, how much can he swim? Well, we're going to multiply this by the reciprocal, which is 8 over 5. And then 8 over 5 here on top. So you can use your calculator. So, but the bottom one, it's easy because it simplifies to 1. And then 2 times 8 over 5 is 16 over 5. Or 5 goes into 16 3 times. 1 left over, 3 and 1/5 miles. So this is probably the better answer. 12. Tony drinks da 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 da. So let's do Tony over here. 5 pints of water in 6 minutes. That's a lot of water. In 6 minutes. And then Mark drinks 8 pints of water in 4 minutes. So the question says, who drinks more after 1 hour? Well, so let's find out. So we're going to find out how much in 1 hour. 1 hour is the same thing as 60 minutes. So I'm not going to write hours. I'm going to write minutes. Okay, so in 60 minutes, how much does Tony drink? In 60 minutes, how much does, Mark drink? So is there a relationship? Times 10, right? So I can do times 10 on the top. So it's going to give me 15 pints. So in 1 hour, Tony drinks 50 pints. Is there a relationship here? 4 times 15, yes, 60. So on the top is times 15. And 8 times 15 is 0 for 120 pints. So after 1 hour, who drinks more? Mark does. 13. What is true about this graph? The rate is 40 miles per hour. Well, let's see. In 1 hour, he goes 40. No, he goes 30. So put a 30 here. So A is not true. B, the unit rate 60 cookies per hour. Well, this should be all miles. Okay, not cookies. So miles should be all miles. The unit rate 60 miles per hour. Well, again, in 1 hour, does it look like he goes 60? No, it doesn't. So this is wrong. C, the unit rate's 30 miles per hour. Well, that one seems right. 1 hour, he goes 30 miles. So C is correct. So D, I'm not even going to bother checking. So the correct answer would have been C. 14, find the constant proportionality. Are they all the same? How do you know? Well, let's do A, let's do B, and let's do C. So for A, be K equals Y over X. The Y is this, the money, and the X is the bag of chips. So for A, it would be 25.5 divided by 17. Is 25.5 divided by 17, and K is going to be 1.5. For B, it's going to be 49.5 over 33. Let's see if that's the same. 49.5 divided by 33, and that is also 1.5. Look at that. And C would be 13.5 divided by 9. And that's going to also give 1.5. So in this case, all the constant proportionality for all three bags are the same, which means they all have the same unit rate, right? So over here, each bag of chip was $1.5, and over here, the bag of chips was 1.50, and the last one, each bag also was 1.50. So that's what it means here, okay? And if you were to write the equation, it would be 1.5x, and this one would also be 1.5x, and the last one will be y equals 1.5x. Okay. 15, a recipe, blah, blah, blah. The recipe requires 2/9 of a pound of chocolate for every. So you get 2/9 for chocolate, and you need 7/8 of raisins. Okay, so what happens when I have 1 pound of raisin? So how much chocolate will I need? Well, let's multiply this by the reciprocal. I'm going to multiply the top by the reciprocal too. This simplifies to 1. And over here, 2/9 times 8 over 7. This is going to be 2 times 8 is 16. 9 times 7 is 63. So you're going to need 16 over 63 pounds of chocolate for 1 pound of raisin. Okay. Which is not even 1 pound. 16, tell whether the relationship is proportional. Explain why or why not. So we're looking at this relationship, right? Are they all the same? So obviously this is x, and this is going to be y. So let's divide 58.5 divided by 9, 65 divided by 10, 71.5 divided by 11. And we can then check if it's proportional. So 58.5, so I'm going to do k equals y over x. So the first one I'm going to do is 58.5 over 9. That's going to give me, divided by 9 equals 6.5. So now I got to just figure out if, so if the k is 6.5, so this is 6.5. So 9 times 6.5 is 55.8. It's 10 times 6.5, 65, yes, so check. How about 11? 11 times 6.5, that's going to give us 71.5, so that's a check. And then 12 times, so again, times 6.5 times 6.5, because that's our unit rate, right? So 12 times 6.5 equals 78, so that's a check. And the last one, 13 times 6.5 is 84.5, that's also, so the unit rate, so this is a proportional table, right? And my equation equals y equals 6.5x. It doesn't matter which one I use, I will always get the same. So it does mean that whatever this is, every single thing that I buy is 6.5. Okay. 17, Jake uses, I'm thinking you missing a word, uses 4/7 of a yard of fabric to make a t-shirt. He wants to make 8 t-shirts, so 4/7 of fabric. He makes 1 t-shirt. If you want to make 8 t-shirts, how much fabric does he need? Times 8, right? So I'm going to multiply this times 8. I multiply this times 8, it'd be 7 times 8, it's going to be 32 over 7. Or 7 goes into 32 4 times, which is 28, and then 4 over 7. So 4/7 of a yard of fabric. 4/7 of, this is not fabric, yards. 4 and 4/7 yards of fabric he's going to need to make 8 t-shirts. What point in the graph below describes the unit rate? So let me find the graph first of all. So the unit rate is always going to be when your x value is 1. So we look for the x value. In this case is right here. So the unit rate is this guy right here. So the point would be 0.1, comma 5. Okay. 19, complete the table. And again, this is almost like the previous question. You can find, again, this will be your y, actually your x, because it's time, and words would be y. So let's do this guy here and find k. So k would be 81 divided by 6, and k equals 81 divided by 6, k equals 13.5. So that's my constant proportionality. So 6, I'm going to erase this, 6 times 13.5 is 81. So all I have to do is multiply everything by 13.5 times 13.5. 1 times 13.5 is 13.5, so that one is easy. 8 times 13.5 is going to give us 108. And 15 times 13.5 is going to give us 202.5. Okay. So Katie earned $4,608 in 4 hours. Wow. How much did she earn in 1 hour? That's not that bad. So it's 4,608. 64 hours. So in 1 hour, let's divide this by 64. Let's divide this by 64. So we're going to get 4,608 divided by 64. And per hour, she makes $72. Wow. I wish. 21. Tony sells pizza pie, bought 18. So I think I'm missing the word here. Bought 18 pizza pies for $333. Write an equation to represent the relationship. So the money is going to be my y, and the 18 pizza is going to be my x. So if I do k equals y over x, k is going to be 333 divided by 18. 333 divided by 18, that's going to give me, and k is going to give me 18.5, which means my unit rate, right? So it's going to be $18.50 for 1 pizza pie. That's my unit rate. And then my equation is going to be y equals k times x, or y equals 18.5x. 22. True fact, there's a house fire every 8 minutes in the USA. So how many fires happen in 1 day? Oh my god. So one house fire every 8 minutes. So we want to find out how many is it in 1 day. Yeah, but here is in minutes and here is in days. So I have to find out. I'm going to change this and figure out how many minutes there are in 1 day. Okay, so I'm going to change that. So 1 hour has 60 minutes. Yeah. 2 hours would be 120 minutes, right? Because we're doubling. 3 hours would be 180 minutes. So In one day, there are 24 hours. So if I multiply 24 times 60, there are 1,140 minutes in one day. So instead of writing one day, I'm going to write 1,440 minutes, which is the same thing as one day. So let's find the relationship. So 8 times what is 1,440? So I can divide 1,440 divided by 8. And I'm going to get that's times 180. So over here, it's times 180. So the answer is 180 house fires. That's a lot of fires. You really get careful with fire. 23. What is the constant of proportionality on the graph below? Well, let's pick any point. 2, 4, 6, 8. Well, let's pick this point right here. That point right here is 4, comma 2. Right? The x is 4, and the y is 2. So to find a constant proportionality, I do k equals y over x. K is going to be 2, and x is going to be 4, and 2 divided by 4 is 0.5. Right? So it doesn't matter which one you pick, this one, or 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 even this one. You would again k equals 0.5. When if they wanted the equation, you would write 0.5x. 23. A rhombus is a shape that has 4 sides. So this sort of looks like a rhombus. All right, so we're asking for the equation, right? So let me show you something over here. So this is side, this is perimeter. Now imagine a rhombus that has a side, each side measures 1. How much would be the perimeter? Well, the perimeter would be 1, 2, 3, 4 because you're adding, right? So when the side is 1, the perimeter is 4. When the side is 2, when each side measures 2, 2 plus 2 plus 2 plus 2 would be 8. So when the side measures 2, the perimeter is 8. What about when it's 3? 3, 3, 3, and 3. 3 plus 3 plus 3 plus 3 is 12. So when each side measures 3, the perimeter is 12. I'm hoping you can see a relationship here. What about when it's 4? So when each side measures 4, the total would be what? 4 plus 4 plus 4 plus 4, which is 16. So is there the same thing going on here? Is the constant proportionality is the same, right? So it's times 4, times 4, times 4, times 4. So k is 4. If you want to write an equation, it would be y equals 4 times x, right? 25, 26, 27, 28. Oh my god, okay. 25 is a Best Buy question. So let's do A. Oops. A, you have an orange juice, which is $8.40 over 20 ounces. B is $10.15 for how many ounces? 35 ounces. So which one is better per ounce? So 1 ounce, 1 ounce. So let's divide top and bottom by 24. 8.4 divided by 24. If you look at it, it's going to be 35 cents per ounce for this. This one we divide by 35. Divide by 35. 10.15. And we get that each ounce is 29. So which one is the better buy? This guy. But we're not asking. They're asking what's the difference in price. Well, it's 0.35 minus 0.29. So the difference would have been 0.04. And this is the answer that they're looking for. What's the difference per ounce? 4 cents per ounce. Okay, okay, 26, 27. All right, so Mary walks 35 miles in 17 miles, 34 minutes. So this is my y, and this is my x. How many miles does she walk in 1 minute? What is the equation of the line? So let's find k. K equals y over x. K equals y, which is 17 over 34. And that's going to give us 0.5. So if I write my equation, y equals 0.5x. Yeah. So when it's 1 minute, I would put 1 over here. 1 times 0.5 is 0.5. 2 times 0.5 is 1. 3 times 0.5 is 1.5. And 4 times 1.5 is, I'm sorry, 0.5 is 2. Right? So it's always 0.5 times 0.5 times 0.5 and times 0.5. Okay, so based on that information, I can create a graph. So if I took this to the graph, this is minutes and hours, minutes and something, minutes and miles. So over here, it's minutes. And over here is miles. So I want you to use the information in your graph. So we had 2 and 1, right? You got 4 and 2. You had 3 and 1.5. And you had 1 and 0.5. So you could have created, you could have created a better graph than this. Okay, that would have been your equation y equals 0.5x, where 0.5 represents the number of miles he walks in 1 minute. And that would have been your equation. Okay, so it's not that difficult, but you definitely need to know a couple of things. Okay.